Hey there, embedded engineers. Ever wondered how to secure the boot up process of U-boot on an Stm32 ARM64? Well, you're in the right place. Today, we're diving deep into this crucial aspect of embedded system security. We'll explore the Stm32 Trust solution and how it can enhance your product designs. So, let's get started. First things first, what exactly is Stm32 Trust? It's a comprehensive security framework developed by ST Microelectronics. This solution provides a multi-level strategy to boost security in new product designs. It's specifically designed for Stm32 microcontrollers and microprocessors. And it works in conjunction with STSAFE secure elements. Now, you might be wondering, what makes Stm32 Trust stand out? Well, it offers a set of 12 security functions. These functions cover hardware, software, and design services. They come from both ST and third-party providers. This comprehensive approach ensures compliance with new national regulations and security standards. Let's break down these security functions a bit more. On the hardware side, we have Secure Boot and Secure Firmware Update. These are crucial for maintaining the integrity of your system. Then there's device identity and strong authentication. These help prevent unauthorized access to your device. Moving on to software functions, we have cryptographic libraries. These are essential for implementing various encryption algorithms. There's also secure key storage and management. This ensures that your cryptographic keys remain safe and protected. Now, let's talk about the design services. Stm32 Trust offers security evaluation and certification support. This is incredibly valuable when you're trying to meet specific security standards. There's also training and consultancy available. These services can help you make the most of the Stm32 Trust framework. One of the key strengths of Stm32 Trust is its alignment with industry certifications. It relies on several security certification schemes. This increases your confidence in the security implementations. Two major certification schemes are worth noting here. First, we have Platform Security Assurance, or PSA, defined by ARM. This provides a framework for securing connected devices. Second, there's the Security Evaluation Standard for IoT Platforms, or SESIP. This is defined by Global Platform and focuses on IoT security. It's worth mentioning that the STSAFE secure elements are common criteria EAL5+ certified. This is a high assurance level that adds extra credibility to the security framework. Now, why does all this matter to you as an embedded engineer? Well, these certifications allow you to use the Stm32 Trust framework with more confidence. You can more easily meet the security requirements of various standards. These include PCI, UL 2900, IEC 62443, ETSIN 303645, and FIPS 142, among others. Let's dive a bit deeper into securing the boot-up process of U-boot on an Stm32 ARM64. This is where Stm32 Trust really shines. The Secure Boot function ensures that only authenticated firmware can run on your device. This prevents attackers from replacing your firmware with malicious code. Here's how it works in practice. When your Stm32 ARM64 device powers on, the boot ROM verifies the first-stage bootloader. This bootloader is typically stored in on-chip flash memory. The verification process uses cryptographic signatures to ensure authenticity. Once the first-stage bootloader is verified, it loads and verifies U-boot. U-boot, being a universal bootloader, is crucial for initializing hardware and loading the operating system. Stm32 Trust provides mechanisms to secure this process. One key aspect is the use of a Hardware Security Module, or HSM. The HSM stores cryptographic keys and performs secure operations. This prevents the keys from being exposed to potential software vulnerabilities. Another important feature is secure storage. This ensures that sensitive data, like encryption keys or device-specific parameters, remains protected. Even if an attacker gains physical access to the device, they can't easily extract this information. Now, let's talk about implementing this in your own projects. First, you'll need to configure your Stm32 ARM64 device to use Secure Boot. This typically involves setting specific option bytes in the device's flash memory. You'll also need to generate and program the necessary cryptographic keys. Next, you'll modify your U-Boot configuration to support Secure Boot. This involves enabling certain config options in your U-Boot build. You'll also need to sign your U-Boot image using the keys you generated earlier. It's important to note that Secure Boot is just one part of a comprehensive security strategy. You should also consider implementing secure firmware updates. This ensures that your device can receive security patches and feature updates safely. Stm32 Trust provides tools and libraries to implement secure firmware updates. These typically use cryptographic signatures to verify the authenticity of update packages. They also often include rollback protection to prevent downgrade attacks. Another crucial aspect is secure debugging. While debugging is essential during development, it can be a security risk in deployed devices. Stm32 Trust offers mechanisms to disable or restrict debugging capabilities in production devices. Let's not forget about runtime security. Stm32 Trust provides features like ARM Trust Zone technology. This allows you to create isolated secure and non-secure worlds within your application. Sensitive operations can be performed in the secure world, protected from potential vulnerabilities in the non-secure world. Now, you might be wondering about the performance impact of all these security features. It's a valid concern, especially in resource-constrained embedded systems. The good news is that many of these features are hardware-accelerated on Stm32 devices. This minimizes the performance overhead while still providing robust security. Let's talk about some best practices when implementing these security features. First, always use the latest version of Stm32 Trust and associated tools. Security is an ever-evolving field, and updates often include important security fixes. Second, carefully manage your cryptographic keys. Use a hardware security module or secure key storage whenever possible. Never hard-code keys in your source code or store them in plain text. Third, implement defense in depth. Don't rely on a single security measure. Combine multiple layers of security to create a more robust system. Fourth, regularly update your firmware. Even with Secure Boot, vulnerabilities can be discovered over time. Having a secure update mechanism allows you to patch these vulnerabilities. Fifth, consider the entire lifecycle of your device. Think about security during manufacturing, deployment, operation, and end of life. Stm32 Trust provides features to support each of these stages. Now, let's address some common challenges you might face. One is managing the complexity of security implementations. Stm32 Trust aims to simplify this with its comprehensive framework and tools. However, it's still important to have a good understanding of security principles. Another challenge is balancing security with usability and performance. It's tempting to enable every security feature available. However, this might not be necessary for every application and could impact performance or user experience. A third challenge is keeping up with evolving security standards and threats. This is where ST's ongoing support and updates to Stm32 Trust are valuable. They help ensure your security implementations remain current and effective. As we wrap up, let's recap the key points. Securing the boot-up process of U-Boot on an Stm32 ARM64 is crucial for system integrity. Stm32 Trust provides a comprehensive framework to implement this and other security features. It offers hardware and software functions, along with design services. The framework aligns with important industry certifications, increasing confidence in its security implementations. Remember, security is an ongoing process, not a one-time implementation. Stay informed about the latest security developments and best practices. Regularly review and update your security measures as needed. If you found this information helpful, please give this video a like. Share it with your fellow embedded engineers who might benefit from this knowledge. And don't forget to subscribe for more content on embedded systems and security. Thanks for watching, and happy secure coding.